All right, now we're going to do the notes for 5.5. Now 5.5 has kind of 2 or 3 sets of identities. One set that we'll use a lot, 2 that we just barely use. The set that we use a lot are called the double angle identities. And they're on here. You notice it's when you have the cosine of 2a. So you're looking for the angle when it's like 2x or 2 theta, something like that. Notice for cosine, there's 3 of them. You can use any of the 3. It kind of depends. Sometimes it's just your choice. Sometimes one will be easier than another one. So one of them is, so you're going to figure out what a is. One of them is cosine squared a minus sine squared a. So you can take the cosine of a and square it minus the sine of a and square it. Another option is 1 minus 2 times sine squared a. So 1 minus 2 times the sine of a, all sine of a squared. The other one is 2 cosine squared a minus 1. So you take 2 times the cosine a squared and then subtract 1. For sine, and these all came from, actually, if you took the cosine of a plus b, only made it a plus a, that's where these come from. The sine of 2a, 2 times the sine of a times the cosine a. And the tangent of 2a is 2 times the tangent a on top, on the bottom 1 minus tangent squared a. Again, all of these came from just taking the sum and difference ones we just did and making it a plus a instead of a plus b. Okay? So, I'm going to use that identity sheet a lot again. If we look at this first one, it says, write as a single trig function or a single number. So you look at this, always want to look at that identity sheet. Do you see anything that looks like cosine squared minus sine squared? Well, if you look at that first double angle identity, it says cosine squared a minus sine squared a. So you can see those look alike as long as a is 7x. So this matches the right side of that identity. So we know that a is 7x. So if we put that on the left side, that's the cosine of 2 times a. So that's the cosine of 14x. Now some of these are a little trickier, like this one. Notice it says the sine of 15 cosine of 15. Well, that looks sort of like the sine one. Notice it says 2 sine a cosine a. We have sine a cosine a, but we don't have the 2 in front. Well, if I put a 2 in front, so let's say I put a 2 in front of here, that makes it match, but we don't want to. So I'm going to do that here, and I'm going to put a 1/2. So you can see now I essentially have the same thing. I just rewrote it so that this part in here matches an identity. So that's 2 sine a cosine a. So if we plug it in, that is the sine of 2a. So that's the sine of 2a. Now we know a is 15. Can't see that. So that's the sine of 2a, and a is 15 degrees. So this right here is the sine of 2 times a. And we still have a 1/2 out front. So we did this. It looks like a weird thing to do, but we did this to make this inside match. So we put a 2 in front to make it match. To balance that out, we put a 1/2 out front, so that would cancel it out if we wanted to. Well, let's see. Now if we look at that, that's 1/2. 2 times 15 is 30. That's 1/2 the sine of 30. Well, we know the sine of 30 from our triangle. We know our triangle looks like that. We know the sine of 30 is 1/2. So this is 1/2. The sine of 30 is 1/2. So 1/2 times 1/2, we can simplify that all the way down to 1/4. Now this next one, again, this is like those problems I warned you. We'd be doing these all the time. So here, we're trying to find the sine of 2 theta. Well, let's look at our sheet and write down the identity. The sine of 2 theta equals 2 times the sine of theta times the cosine of theta. We just got that right off our identity sheet. Well, now they told us the cosine of theta is 3/5, so let's put that in. The cosine of theta is 3/5. Well, now we need to find the sine of theta. Well, let's draw a triangle. If we draw a triangle, it says cosine is positive. Well, cosine is positive in quadrants 1 and 4. The sign is negative. That's quadrants 3 and 4. So we know we're in quadrant 4. So let's draw it in quadrant 4. Let's go down here in quadrant 4 and draw our triangle. We know the cosine is 3/5. That's adjacent over hypotenuse. Let's see, 25 minus 9 is 16. So this side is 4, and we want to make it negative since it's down. So that means the sine of theta equals opposite over hypotenuse, negative 4/5. So for sine of theta, we put negative 4/5. Well, let's see now, if we multiply that out, on the top we have 2 times negative 4 is negative 8, times 3 is negative 24. On the bottom we have 1 times 5 times 5, 25. So that's the sine of 2 theta. Cosine of 2 theta, well, we have an identity for that. Again, we have 3 of them. Now on this one, I would probably choose this very first one, this third one, I mean, because they gave us the cosine, so we know that one's right. It was given. So that's why I would use this third one, because it's got just cosine in it. So if we use that one, if we write that out, 2 cosine squared theta minus 1, now we substitute in, the cosine of theta is 3/5. That's going to be 3/5 squared minus 1. So that's going to be 2. 3/5 squared is 9 over 25 minus 1. So that's going to be here, if we multiply 2 times 9 is 18 over 25. 1 is 25 over 25. So 18 minus 25, negative 7 over 25. So that's our cosine of 2 theta. Now for tangent of 2 theta, you have 2 choices. We could use the identity. We could look up the identity for the tangent of 2 theta, or since we know the sine and cosine, we have that quotient identity that says tangent equals sine over cosine. So here we know the tangent of 2 theta is actually the sine of 2 theta over the cosine of 2 theta. Well, we already have those. The sine is negative 24 over 25. The cosine is negative 7 over 25. So if we substitute those in, so we know the tangent equals sine of 2 theta over cosine 2 theta. We know the sine is negative 24 over 25. The cosine is negative 7 over 25. So we have this big fraction. Now if we take the top times the reciprocal of the bottom, we can divide top and bottom by 25. We have a negative 24 times a negative 1, that's 24. And 1 times 7 is 7, so that's our tangent. So you could use one of the identities, or we could just use that. Okay? The next one says find the sine and theta and cosine given that the cosine of 2 theta equals 3/5. So here, notice it says the cosine of 2 theta. Well, we have identities for those. Now we want to pick one of our identities that only has one other in it. So we want to use either this one, 1 minus 2 sine squared, or this one, 2 cosine squared minus 1. We want to use one of those two. It doesn't matter which one of those two. Let's say we didn't use this one before. Let's use 1 minus 2 sine squared. Okay, it doesn't, I don't know. I would probably be tempted to use this one. So yeah, since they gave us cosine 2 theta, I would use that one. I'm sorry, it doesn't really matter. So let's say we chose that third one. So let's write it out. The cosine of 2 theta equals 2 cosine squared theta minus 1. Now let's plug in. We know the cosine of 2 theta is 3/5, so that goes over here. So now we have this. Now we need to solve for cosine. So first, if we add 1, well, adding 1 is like adding 5/5. So now we have 8/5 equals 2 cosine squared theta. Now we want to divide by 2, If we divide by 2, 8/5 divided by 2 is 4/5. Now we want to square root both sides. So that's plus or minus. Square root of 4 is 2. Square root of 5 we don't know. Now all we have to do is decide if it's plus or minus. Well, notice it says theta is in quadrant 1. Well, if we're in quadrant 1, cosine is positive. So that's a positive 2 over radical 5. That's a couple of ways to use those. Oh, I'm sorry, we still have to find sine. What I would do to find sine is I would draw this now. We know we're in quadrant 1. I would draw it in quadrant 1. We just found the cosine is 2 over radical 5, so the adjacent is 2. The hypotenuse is radical 5. Let's see, 5 minus 4 is 1, so this side is 1. So our sine of theta is opposite over hypotenuse, so 1 over radical 5. Or if you want to change it to radical 5 over 5, that's fine. All right? So that's that part. Now I mentioned there's actually some others here. These are formulas that we very barely use, and that's the next two. These are called product to sum and sum to product. Product to sum, notice if you notice it says product to sum. Notice the left side is a product. Cosine times cosine, sine times sine, sine times cosine, cosine times sine. That's what it means, product to sum. The left side are products. Notice on the right side, their sums, actually sums and differences. So that's those. So if you're given a product, and they ask you to convert it to a sum, you just look up the appropriate one. Like if we look at this first one, this next example says, write this as a sum or difference. Well, notice right now it's a product. It's a product of two things. We want to write it as a sum, so we look it up. Notice it says cosine times sine. So we look up the one that says cosine times sine. Well, this very bottom one says cosine A sine B. So that's the identity we're going to use. So A is 85, B is 40. B is 140, sorry. Now notice there's a 2 out front that's extra, so we're going to start with that. So we're going to have a 2. Now we use the identity. Cosine sine. So the identity says we need a 1/2, so we need a 1/2. Now we need the sine of A plus B. So that's the sine of A, which is 85, plus B, which is 140. So the sine of A plus B. Then it says minus the sine of A minus B. So minus the sine of A minus B. So all we did was we just looked at this and looked up the identity. So that's the sine, so it's 1/2 times the sine of A plus B minus the sine of A minus B. Now we can simplify a little bit. Notice here we have a 2 on the outside and then a 1/2. Well, we can multiply those together and just get 1. Now we have the sine of 85 plus 140. That's the sine of 225. Minus the sine of 85 minus 140. That's what, 55? So that's the sine of a negative 55. So notice it says write as a sum or difference, so we changed the product to a difference. Just plugged into that formula. That's all we will do with these, is exactly that. Look it up, plug the numbers in, simplify where you can. Now the next set is the opposite. And we just did product to sum. The next set says sum to product. So notice all these, the left side is a sum or a difference. So sine of A plus the sine of B. Sine of A minus the sine of B. Cosine of A plus the cosine of B. Cosine of A minus the cosine of B. So the left side are sums and differences. Notice the right sides are products. 2 times sine times cosine. 2 times cosine times sine. 2 times cosine times cosine. Negative 2 times sine times sine. So we're going to do the same thing. Like this one says, write as a product. Well, you notice right now it's a sum. That's cosine plus cosine. So this is like A and this is like B. So we're going to look for cosine plus cosine. Well, if you look, this third one down is cosine A plus cosine B. So we're going to use that one. So if we use that one, so I can see both of these. Probably not. So it's this one right here. So we use that identity. We're going to have a 2 cosine. Now it says a plus b over 2. That'll be 5x plus 8x over 2. And then cosine again. Now a minus b, that's 5x minus 8x over 2. We can simplify just a little bit. We leave the 2. Here, 5x plus 8x is 13x over 2. Here, 5x minus 8x is a negative 3x over 2. We changed it to a product now. And that's it, we're done. Okay? Now, a couple of verify problems. So look at this one. Again, we're looking especially for ones we talked about in this section. Here, notice on the left we have 1 plus cosine 2x over sine 2x. Well, here, if you look at this, that's a double angle. Whenever you see a 2x, you think double angle formula. Here's another one down here, double angle formula. So let's look at our identity sheet and plug something in here. Now on this one, on the bottom, the sine of 2x, the identity for that is 2 sine x cosine x. So that's going to go on the bottom. On the top, we have 1 plus. Now for the cosine of 2x, the hardest thing about this is which one to pick. Well here, since we have a 1 in front, notice the third one has a negative 1 in it. So I would pick that one, because now if we have that 1 in front, if I use that one, so 2 cosine squared a minus 1, so 2 cosine squared x minus 1. If I use that one, now this 1 and this negative 1 cancel each other out. So now, so we can see it clearer, on the top I have 2 cosine squared x. On the bottom I have 2 sine x cosine x. Well, let's see what we can do with that. Well, I have a 2 and a 2, so I can divide top and bottom by 2. I also have a cosine squared and a cosine. I can divide top and bottom by cosine. That gets rid of one of these and this one. So now I'm left with cosine x over sine x. Well, from our identity sheet, cosine x over sine x is cotangent x. And they match. So when you see a 2x, right away you think, ooh, double angles. I have identities for that. Okay? Let's look at this next one. Here, so on the left I have the sine of 4x. Here I have 4 sine x cosine x minus 8 sine cubed x cosine x. Now first, when I see a sine cubed, we don't have anything with a sine cubed in it. So I would like to change that. Well, look at these two things. What do they have in common? They have a 4. I can take a 4 out of both, so let's take out a 4. They each have a sine, so let's factor out a sine. And they each have a cosine. Let's factor out a cosine. If we factor that out, if we take this divided by that, we're left with 1. Here, 8 divided by 4 is 2. Sine cubed divided by sine is sine squared. And cosine divided by cosine is just 1. So if I factor it now, it looks like that. Well, now I see a couple of things. First, this right here, look at your identity sheet. You see in our double angle identities, we have 1 minus 2 sine squared. Notice one of our identities for double angles is 1 minus 2 sine squared. So if we have that, that equals the cosine of 2a. So this right here equals the cosine of 2a. So that's the cosine of 2x. Now this front thing, that looks almost like this one. Notice I have 4 sine x cosine x. Here I have 2 sine x cosine x. So it looks very similar, except I want a 2 and this one has a 4. Well, could we make that 2 times 2 sine x cosine x? Could we just rewrite it like that? So now we have an identity for that. That's the sine of 2x. So now I have a 2 out front. We said that is the sine of 2x, and that is the cosine of 2x. Now we're not quite done, because if you look at that, if I said 2x is a, Doesn't that say 2 sine A cosine A? 2 sine A cosine A. So that matches that identity, but now A is 2x. So if we go to the left side, if A is 2x, that equals the sine of 2A, and we said A was 2x, so it looks like that. Well, that's the sine of 4x. And we simplified it. Oh, I'm sorry. Yeah, let's put this, sorry, I lost track. So that's the sine of 4x. Well, notice that's what we had on the left side, so we're verified. Okay, that is 5.5.